fmtraining.tv. My name is Margaret. I'll be your broadcast engineer for today. I am here with the wonderful I almost said Hans Hints, which is incorrect. You are not combined as a creature named Hints or
Hence.
Bonza. I'm here with the wonderful Vince Minano and Hansa Koldeka. They have been doing an occasional Thursday thing with us where they discuss basically the FileMaker platform and all the cool myriad things the FileMaker platform can do, or they break down to really nitty gritty. It's been a real pleasure. We started an index conversation, I think, 2 weeks ago, which we are continuing now. Uh, which I know I was talking to Jacob Taylor actually about it the other day. It was a really great presentation, and that tool is fantastic. You should definitely go implement it if you need it. I think it is worth its weight in gold. I think I'm pretty much keen to hand it over. So, how are you two doing? What are we talking about today?
Well, we're doing fine, and actually, we didn't start talking much about indexes last time. We talked about file size and what
That's
the
true.
file size consists of. And I have a great update for that because I think it was Dan Shockley who contacted me that he tried it on a client file around 50 gigabytes, I believe.
Ooh.
Uh, and he tried that nice script that I was showing last time. Uh, and I can show you on my screen on our website, which this is it, 240software.com. On the news, one of the latest news articles is what has eaten my disk space. That was the last time's topic, and here I shared a script that where you can download that utilizes the FM developer tool to kind of analyze the size of the FileMaker file and give you a clue of how many bytes are occupied by which field and which index and so on. The problem with this is that the FileMaker developer tool takes a lot of time to analyze big file. And Dan contacted me with a question like, I started the script about 20 hours ago, and it still hasn't given me a single line of results. So he was wondering whether he can safely interrupt it or run it multiple times or something like that. And as we communicated briefly over email, I discovered one potential optimization thanks to Vince because he noticed in the FM developer tool. Uh, Wait a minute. Uh, there are the commands that we are using, which is basically sort by size. This is the command that we are using. And
And the
when you
one
run
above it.
And when you run that command uh, without extra parameters, like I can use it like for the database I have just created a moment ago, and should be new browser. Okay. How can I run it with an empty password, by the way? What is the I don't use it manually too often, so I never know. Let's try without. No, it keeps
You have to
asking me.
use the command. You're not using the command. You're just saying the
Oh
file
yeah,
name.
you're right. Sorry. Sort by size. I always forget
Yeah.
this.
You have to plug in the device before you can start using the toaster.
That's funny. Anyway, this is a database with just one table, and Vince recently discovered that this single command, listing all the tables, takes more time than if you aggregate all the time running it by table by table. So, and my script actually uses this first command just to get the list of all tables so that I can loop through the individual tables to get the detailed stats for each one of them. So what I have done just yesterday is I slightly optimized this script. So whoever has downloaded it last time, re-download it because I have added one extra thing here, and that's sorry, this is the prompt. I wanted the script itself. Wait a minute, where is it? Doo-doo. Okay, so here was the script somewhere here. So in this script, I start by getting the list of tables. So what I added is that instead of running that first command on the full size file, I actually start by creating a clone of that file and then run the first sort by size on that clone, which is creating the clone takes just a few seconds, and running this on a clone takes just a few seconds. So basically, I cut the time needed for the script to run to less than a half with this simple trick.
Wow, cool. And it's
So
already on the website?
it's already on the website, it's updated. So if you re-download it from that article, you get the faster version now.
Thank you.
So that's the update from last time. I actually when I run the script on that SEM file, empty fmp12, and it gives me this nice overview. Uh, it takes some time, even on a very small file, but it's actually not small because I have just created a million records in it 5 minutes ago. But it gives me this overview when if I actually put it into a file, as I showed last time, uh, I can then convert that file and see the breakdown in a FileMaker very nicely and work with it. But the interesting thing is that what we are going to focus now on, let's do this conversion to FileMaker. Wait a minute. So that's, we use field names and oh, this is a weird bug in FileMaker, by the way. If you switch between dark mode and light mode using a shortcut, it breaks FileMaker user interface.
Really?
Hmm.
I have not run into that yet.
Yeah, but if you do it manually in the system settings, it's fine. If you use a shortcut to switch the dark mode to light mode and vice versa, it breaks the new nice appearance of the table view. Anyway, these are the stats for the just recently created file where I added million empty records. And what we are going to focus now is indexes. And before I dive into FileMaker, guess what was the number one? You know that I do optimizations for more than 15 years now. And I don't optimize only FileMaker solutions. I sometimes get to optimize something else as well. And guess what was the number one way to optimize the performance of a MySQL database? I just went to the solution, looked for what fields the solution was querying, and I enabled indexes for them.
And to
Because
get that, yeah.
because in MySQL, by default, there's only one index created, and that's for the primary ID, primary key field, nothing else. Contrary with FileMaker, uh, you see that I have created some fields. This is empty database, and in that empty database, I have no records. So I will run it later again. I open this empty database here, and I have created million records here. So in FileMaker by default, when you create a new field, it looks like this. There is nothing here in this last column, and there is this storage setting where it says indexing none, automatically create indexes as needed. So let me do something. It will take a moment, and while it takes time, we can talk. But let me just close this, and I will generate UUID into this text field for all the million records. So I will replace field contents of million records with UUID, which will take some time, but not very long. So it's taking just a few seconds here. And when I go back to the database definition, there will be still no index created for this field. So there are a million unique values in this field. And when I go back here, there is nothing. Indexing is still turned off. But when I try to search for something, let's say I do perform find and type 5 here and press enter. Now this will be taking some time. And you see updating index for field UUID. So now FileMaker is building an index for that field. An index is a B-tree structure which basically puts every value from that field into a node, and the node has the IDs or a list of record IDs that contain that value. So basically, when FileMaker, when you do search on a field that's indexed, it goes to that B tree, find that value that you're searching for, and on that node, it immediately gets the list of records that it's supposed to return. So, what do you think will happen now when I have the index? How quickly it will find records that, let's say, begin with 6?
Very fast.
So I put 6 here, press enter, I have them. So it's fraction of second. This is because of the index. I see the field is indexed now, and because it's indexed, finding records is extremely fast. But what I also need to note is that there are unique values for this UUID. So every record has a different value in this field, which means for every single record, the index has a separate node listing just one record ID. If I generate, let's say, do we have some lorem ipsum generator? Oh, I can just find some sample here and copy block of text. And let's copy like 50 paragraphs so that it's long enough. And I'll put it in this lorem ipsum field, which is another text field. And then I will copy to all those million records. So it will just be the same value for all million records. I'll just replace all million records with this value.
You're only doing 106,000 records because you're
Oh,
found. Yeah.
oh, sorry, you're right.
I didn't
But
even notice that.
yeah, good catch.
One didn't want to wait for the sequel.
So it will take a little bit longer, of course. So what I want to talk about now, I have million records, but in this case, uh, even if I stop the replies in the middle, the index for this field, I should talk about two indexes, but later on, the full value index for this field will have only two nodes. One for an empty field and one for the value that I have pasted. And each of those nodes will have the list of records containing that value attached to it. So when I analyze this database later, so I will just stop this, close the database, and run the analysis again with my script. Uh, oh, I should do it a little bit later because I have not created the index for the field yet. Um, Yeah, let me interrupt it and I'll create an index. So right now, the lorem ipsum field is still not indexed. When I check the UUID, you see that there is a minimal index. Because FileMaker creates two kinds of indexes uh, for each field. Vince, do you recall how they differ for a text field?
A word index and a value index.
Yeah, so basically, you can easily find it if you do insert, like insert from index. Now that will actually create the other index that I have not created before. So this dialog that will pop up is using the word index, which means uh, when the field contains multiple words, it creates a separate node for each word, not for the whole value. And that's this checkbox, show individual words. So um, it's bad to show it on this field, but maybe if yeah. So I will create an index for this field as well by doing insert from index. So that will create an index for the lorem ipsum field. And that will take a long time, I guess.
Yeah. I mean, maybe you can chop it
Yeah.
down to 10,000 records. Still, I think
Well,
I think it's still make your point.
it will finish faster because I think it doesn't know yet that I have not copied the value to all million records. So it will eventually end earlier. But what I'm going to say is, let's say, wait a minute. Uh, I'll pop up a text here. So when I have like blue, uh, big blue car, so and then I have small red motor cycle. I put in fields like values like this in the field in two records. So what the value index will have is these two values. So if I have I have them multiple times, what the and you see that I have 8 records. So what the value index will look like is that it has one node pointing to records 1, 3, 5, 7. And this node in the index will point to records 2, 4, 6, 8. And the word index will have all the individual words. So it will have big, blue, car, small, red, motor cycle. And again, for each of the words, it will contain the list of records that contain that word. So for instance, if I change this to blue, then I will have another node here, small blue motor cycle. That's in record 8. And for this, for these words, I'll have big will be the same, blue will be the same. Uh, in addition to also the record 8, because the record 8 also contains the word blue. So this is what the it's structured as a B tree, but in essence of in the meaning of what's contained in the index, this is what you can imagine being in the index. Okay?
Okay. So would the index have both the phrases and the single words indexed?
Yes.
Okay.
So basically, this is the value index and this is the word index. And uh, when in FileMaker you see that the choices minimal and all, that means if all is selected, it holds the value index and the word index. Uh, If it's set to minimal, it holds only that index that you have already requested. So now I have only displayed the for the lorem ipsum. I have displayed the dialog here, but I have not checked the show individual word checkbox. So it only generated the value index for now. So this is just uh, it's interesting that it actually generated different values.
Yeah, and I think the reason for that is
And I think
because
it's because it's too big. The text is too big, and it only creates it only considers the first
100
uh,
characters.
100 characters. Yes, for the value index. So next 100 characters is a different value, but it only generated the value index for this field. If I was if I check this checkbox, it would also create the word index. I intentionally don't want to do it for now because now I want to analyze the size of the file finally.
Did you close it? Yeah.
Yes, I did.
Mm.
And now my question for you would be before I have the results, which field is going to have a bigger index, the UUID or the lorem ipsum?
Robert?
So, does anyone have the answer? I
Waiting,
know, I'm
waiting for
sure
people to
Vince.
like respond.
Yeah, and Jason,
UUID.
UID, and it will still take some time.
Part of the issue is that so my other chats are on delays. By the time they can answer the question, you'll have moved on.
Okay, so yeah, I got the report here. So let me convert it to FileMaker again. And here I have the UUID and lorem ipsum. So the data size of the lorem ipsum, even though I interrupted the replace in very quickly, it holds about 100 times more data. But the index size is much bigger for the UUID. And the reason is that the value index only holds those few values that you saw. So it just split it to by chunks of 100 characters each, and that's created the value index. So the value index is very small because there are not too many unique values in the index.
Okay, that's actually good to know. I didn't realize that until you
Another
laid it out that way.
interesting, another interesting thing, and that actually leads to something that Vince wants to talk about, uh, and that's compare the data size and the value index size and the word index size. So for the UUID, if I just split it, so this is 36 million bytes for the data, but it's 74 million for the value index size and 65 million for the word index size. So having the full index for the UUID field means that the index holds, let's say,
39 million.
about 4 times more data than the data itself. So enabling the index multiplied the amount of space this single field occupies by 5.
But if you only searched on the key, then you'd only be searching on a value index. Is that
Exactly.
correct?
So that would not be
So
that worse. So it would be only 3 times more
ah,
space usage. But
only three
still,
times.
the point is that the index takes more space than the values. And now consider you have the file hosted on a server, and you go to that field and use insert from index. What happens?
It goes to a crawl. Well, it depends. I guess it depends what
Yeah,
you're looking for.
it downloads all these bytes from the server to the client. So just to
Oh,
display the, so just to display that dialog, it needs to download 74 megabytes from server.
okay. So it has to be put on the client for the search to actually. Ooh, okay.
Yeah.
That gets
Well,
dicey really fast.
actually, when you perform a find, I think that since FileMaker 16, I believe, or maybe even longer, it tries to do the find on the server, mainly to avoid downloading the index to the client. But there are situations when the client needs the index, and it never does. If I recall correctly, it never downloads only parts of the index. It needs to download the whole index to work with it. So, the bigger the index is, the more data it needs to download from the server when it needs to use the index on the client. So that leads to something that Vitz came up with. There are situations, and you can elaborate that on that, Vince, when uh, partially because of the size of the index, but there are different reasons as well. Completely disabling the index, even for a field you want to search on, may be a good choice. So, do you want to elaborate on that, Vince?
Yeah, I mean, this was kind of inspired a little bit by I think it was Jan from Square Moon. I can't remember now. Anyway, it was at the presentation and Vienna Calling last summer, and he was talking about something about doing an import and not having an index enabled was faster than doing an import on an index field. There was some kind of strange, like it got me wondering, like, wow, maybe maybe we should really consider each case individually and see if we need the index. And so some of my tests were, well, what if I have 1,000 records? I mean, doing a search on 1,000 records is going to be, you probably won't notice the difference and how fast it performs the search without an index versus with an index. At some point, there's a perception where you start to feel like, oh, okay, this is taking more time. But um, yeah, so there's definitely every situation is something that you want to maybe consider the option of enabling it or disabling it more intentionally rather than just leave it the
Mm-hmm.
way it is, which is if you do a quick search, then all the fields in this table that are on this layout would get indexed if they can get indexed. If it's an unstored calc, if it's a summary field, it doesn't get indexed. But I've seen systems where you go into the list of field and you see all the fields indexed, and
Mm-hmm.
what HOnza showed, would only uh, expound on that because then you're really seeing like why is my file 5 GB? It's a small file, but you know you've indexed almost every possible field in every table.
Exactly, and
So
that leads me back to my communication with Dan about the analyzing his 50 gigs file or 80 gigs file, I think. So he came back to me when he finally got some results, and finding out that he can easily remove about between 10 and 20 gigabytes just by disabling some indexes that he knows he doesn't need.
right, so disabling the indexes makes the file smaller, makes backups faster, takes up less space on your server, etc. So, and
And
probably
And by the
that
way, do you recall in the beginning of this stream when I was actually replacing all the million records, filling them with the UID, how long approximately it took? Do you recall that? It was like half a minute, right?
Hmm.
Generating UIDs for million records. Let me try do it now. The same thing I have already done, and it took only about half a minute.
Oh, that is noticeably slower.
Yeah. Do you know why?
Why is it? Well, because is it re-indexing every one that it replaces?
Yeah, because when I did it for initially, there
Hmm.
was no index for that field enabled. The field had the index disabled. So it was only creating the values and nothing else. But now, because the index is enabled, every change in that field that's committed needs to also update the index. And because this has full index, the word index and the value index, it's actually updating two indexes. So with every single record update, it's updating those two indexes as well.
This is kind of a silly question because I don't know why you would want to do this. But if you were to replace every field for some particular reason, would it be smarter to disable the index, replace the field, and then re-enable the index after you've done replacing?
Well, on a local file, it may be, and it's actually faster because it's faster to build the whole index than to keep updating it because when you are updating that B tree, it keeps rearranging that B tree so that it's sorted. So unless you are adding the values in exact the same sort order of the B tree, updating the B tree with every record change is slower than building it from scratch.
does it have to sort it? I guess it does, right? Because it has to
Yes,
be
it's
able to.
it's yes, it's a weighted B tree so that it keeps the B tree split to two halves so that finding for half of the values is equally fast as finding the other half of the values.
Hmm.
So this is uh, much slower because it's updating the index. Now, if I go here and delete this index and I can keep it automatically create index as needed, uh, which basically is required if you want to use that field for relationships. Otherwise, FileMaker will be complaining that you need the field to be indexed to be used in relationships. Uh, Now I have clicked the OK button and you see the beach ball spinning. So now it's removing the index. And guess what happens if you do it on a hosted file? Everyone will be waiting. So it's one of those dangerous things happening when you commit a change in the database schema on a hosted file. That's the reason why you should be never doing it. You should be never making changes in the database structure on a hosted file where you have users connected,
Especially indexes.
especially especially index fields. Exactly. Another example that I talked about last time was when you have a calculated field and you switch it between stored and unstored. So when you switch unstored calculation to a stored calculation on a table with 1 million records, then it's going to update all those 1 million records. So I will try to generate something in the UUID number here uh, to give you a clue of how it differs, how the index differs for number fields.
Let's say I assume it's like much less data and a lot faster, right?
Yeah, the interesting thing about FileMaker is that it stores all the values except containers as text. So even if numbers are stored as text, but they are actually stored in a little bit. I'm not sure if the values or the index. One, I think the index is stored in a slightly optimized way, so it uses only half a byte per digit. So it still stores it as text, but uses only half a digit, half a byte because you can only get from 0 to 9, and you don't need more than 4 bits to store that value. So the number index is optimized this way. The values are stored as text because even in a number field, you can still store any characters. Did you know that?
No, what?
So you can have a number field and you can store text in it. The only limitation is that in a text field, you can store, if I recall correctly, up to 2 GB of text. But in the number field, you can only store up to, what is it? What is that limit? Is it 1,000 characters, Vince?
Uh, I don't remember now. I think I thought it was you mean the numbers themselves, the length of the numbers.
Yeah, the maximum value size for the number field.
I thought it was 400 decimal points either way. So that would be
Uh,
800 numbers.
Well, I think it was, well, I mean the characters of you're talking about still talking about the numeric value, but you can store text with it as well. Like I can type anything here and it's still stored in the field. It's just not it will just not get in the value index because it's not a numeric value, but it will be in the field. I don't recall what that limit is. I think
I'll
it was
try and
pretty
find out.
large. I think it was like 65 kilobytes. It used to be less in FileMaker 6 and earlier, but since FileMaker 7, I believe it's 64 kilobytes what you can store in a single number field, or 65,000 characters or something like that. You can check it
Uh,
out. You can check it out in the help. But anyway, I have filled this field with numbers now.
Mm-hmm.
So let me enable indexes. And now you see for number field, I don't have the minimal option because for numbers, there is only value index. There is no word index for number fields. And I will re-enable it for for the UIDs. So it will take some time to generate those indexes now. So I'll have to wait a bit, but and we can then look at how the size of the index differs for the numeric field. So I don't recall exactly. We will see, but I think for numbers, it's actually going to be smaller than the values, even if they are unique. Do you recall that, Vince?
Uh, Sorry, I was looking up trying to look up the other answer. Sorry, what was your question?
Yeah, with the number index, I think for the number field, the index is going to be smaller than the data, even when they are unique values. But I'm not sure if I recall that correctly. You saw
Yeah,
that for the unique text values, it was double the size of the data, but for numbers, I think it's a little bit smaller. So we'll run it. Okay, so
A little bit smaller or a
now
lot smaller? Are we just going to test and figure that out?
we will find out in a moment. But now I want to talk about one more thing before we get this generated. Uh, and that's an interesting point that Fabrice Norman made in his presentation at Claris Engage. When he talked about FileMaker, he talked about three data layers between in being present available in the FileMaker platform. And guess what the layers are? So he talked about data like schema or metadata or environment layer. Then on the other side, the data layer, and in between the index layer. And it's quite interesting concept because when you open a database, it downloads the schema from the server, especially when it's hosted database. It downloads the schema, uh, and the schema uh, uh, it doesn't even download the whole schema. It downloads it in chunks which you need. So for instance, if you have 100 layouts, it only downloads the layouts that you need. So if you switch to a layout that is not downloaded to the cache yet, it downloads it, it stores in the local cache. But then, because the schema doesn't change until you open until you make changes, it only downloads it once, especially when you don't change the solution, and keeps it in the cache. So everything in the schema is local, unless you make changes, with one exception, which I will talk about a little later. Now, index is per field. So as I mentioned, if you get the if you let's say pop up the insert from index dialog, uh, like here, the FileMaker client downloads the whole index from the server to the local cache, but it downloads the index just for one field. While if you show that field on the layout, if you have 1,000 fields in the record, even if you show just one field on the layout, FileMaker will download all those thousands fields from the server, because on the data level or data layer, it works on based on records. So every time you touch a record, it needs to get the whole record from the server or push the record to the server back when you make changes. Even if you make change to one field, it sends the whole record to the server. So if you have 1,000 fields and in one field you have 10 megabytes of text, which you can have up to 2 gigabytes of text in a single field, and then you have a number field where you change 1 to 2, because there's another field holding that 10 megabytes of text, FileMaker will be sending all those 10 megabytes to the server to save that record. And likewise, it will be downloading all the 10 megabytes to show the record. The only exception are container fields. Those are downloaded on demand, field by field. All other fields, text, numbers, timestamp, are downloaded from the whole record. Uh, and so Fabrice came up with an interesting idea to avoid downloading the whole record. When you only want to show all the values from a field, you can actually use the calculation. You can create a value list based on the field, and you can use the value list items or value list names calculation to get all the values, and that will download the index for that field. So you will get all the values from all the records in that field, but not download. You don't have to download the records themselves. So it's an interesting concept, thinking about index as a data layer that is actually controlled on the field by field principle and not record by record. So
Very
imagine you have
interesting.
imagine you have like two-dimensional view of the database. In one dimension you have fields, and in other dimension you have records. So so let's say fields are columns and records are rows. So on the data layer, you are downloading whole rows. On the index layer, you are downloading the whole columns. So there are cases where you don't worry about the other columns, you worry about one column, and it can be more efficient to download the index than to download the records. There is one more interesting thing that he mentioned, and I keep learning all the time. I work with FileMaker 35 years, and just by watching Fabrice's session, I learned something new. So in the database, and I have a special table for this called globals. When you set up a field to have auto enter, you can set the next value. And you can put any text in the next value as long as it's not longer than, and I will tell you how long. You can retrieve that value using a function, and that function is get next serial value. So here you specify file name and field name. So when I use the current file name and use the, what is it? Globus. So I can actually dereference it, get field name. Sorry, get field name and reference this field here. So with this function, what's wrong with it? With this function, I can extract the next serial value from the field. And in this case, it holds 2,526 characters. And if I recall correctly, that's the limit that I discovered.
Oh,
So, so it's not large, but the nice point is where out of those three data layers this is stored. It's not in the records.
It's a good question.
It's in the schema. The next serial value is in the schema layer.
really? That's where it's kept? Okay.
Yes.
I could not have guessed that.
So even if you save a clone, it persists.
That's cool. Okay.
And it persists per session. So at the schema layer, you can and because you don't only have the you don't only have the uh, uh, function you serial value. So I can put anything here and in that field next serial number, and it's stored there permanently. The only thing you have to avoid is creating new record in that table. Because when you create a new record, FileMaker will increment this value by one.
Okay.
Or by the number that you enter as the next increment. And you cannot change the increment to zero. So when you go to globals,
Hmm.
you cannot change this increment to zero or empty. It needs to be between 1 and 32,767. But as long as you don't create records in this table,
Hmm.
you can store data in the schema layer.
That's kind of
So,
crazy.
so what Fabrice said he's using it for is for storing things like preferences.
Oh.
How? Okay.
Huh.
This is mind blowing.
So, with things like AI, you could think of using this to store your API
Oh.
token.
Really? Okay. Are you good, Vince? What's up?
I don't know.
So it's a crazy thing I learned recently from watching Fabrice's session. It's great, but let's get back to the indexes now, and I will once again convert this text file to a FileMaker file because now I have it analyzed along with the number field as well. And here I have the UID number, and the values themselves take, uh, and this is interesting. The data size is bigger than the UID. Uh, it's natural because the uh, text UID is using hexadecimal representation, so the text UID is actually shorter in terms of characters than the number UID. So this confirms that the numbers are stored as text in FileMaker. But the index is actually about half the size of the data for the numbers. So even though I have unique numbers in every record, the index is smaller than the data.
That's okay. Is that always the case with number fields and indexes?
Yes, and the reason is, as I said, that in the index, it's actually storing one digit per half a byte. So one byte in the number index holds two digits from that number. Because even though we can put any text in the number field, that text does not get put into the index. Index only holds the numeric values of those numbers.
Okay, that makes sense. So there's basically no reason why you shouldn't index number. Well, okay, it's still adding data, so there's that. But indexing number fields is a relatively small weight on a FileMaker file, or it should be, right?
Mm-hmm. Exactly. And there is one more thing. You may have noticed that in FileMaker, we got quite not so a long time before a new option, and I think it's in Perform Find. No,
Oh,
where is it?
refined.
Sorry.
It's constraint found.
Oh, constraint find set. Yeah, you're right.
Mhm.
Uh, In constraint
Constraint
found
find.
set, you got the option to find without indexes. And that's quite important thing when, for instance, we have this file with those million records. And yeah, I have it indexed. So when I look for, let's say, A, it finds me. Okay, let's find for something more unique. So now I have filtered out 12,000 records out of the million. Uh, if I use index for searching, it always has to use the whole index.
Oh, I
Uh,
guess that makes sense, but
because, well, there even when I make a found set like this, it doesn't recreate an index for the found set because that would be extra effort. So the index always is for the whole record set, the whole table. There is no index for the found set, small found set. So so when I do find and now I use like 967 and I want to do constraint found set. By default, it uses the index. So it again searches through the whole database and then it does like a mixture and returns the results, the records which are in both found sets. Which in this case is fine because it's a local file. But if this was a server, it would be calling the server to do the search across the whole index and returning the result back. If I use the script step to search to constrain font set without the index, what it will do on the client, because the client already has the font set and it's already downloaded in the cache in most cases, it will just loop through the small font set on the client and search without using indexes. And in this case, it will be much faster than using it, doing the search with index.
hey, that's good to know.
And yeah, and there is one more case, and one more thing, and that's the case where this is the most important thing, using searching without indexes, and that's when you do find and you use one of these operators. Because when you are searching for exact value, as I mentioned in and I showed you in that text file here, let's say when I look for big blue car, it just finds this single node in the index and gives me the list of records that I want to show. And it doesn't worry about the rest. But if I look for, let's say, something that the value is bigger than let's say foo, it needs to go through all the nodes which match the condition and combine all these found sets together. So this is very simple example, but in a normal case, when I have million records, uh, especially in this case of the unique values, uh, I have million different nodes in the index. So it will need to iterate through how when I search for something that has 50% probability of being there, like bigger than 5 or bigger than 8 would be probably as is hexadecimal. So when I search for this, it will have to go through 500,000 nodes in the index and combine the list of those records to give me the found set. if it was on a server, I would be waiting much longer for this.
Hmm.
And so especially when you use predicates like bigger than, greater than, or equal, or less than, in searches in constraint found set, searching without index is going to help a lot, especially when you are searching within a small found set.
Okay, that's good to know. I wouldn't have thought, I mean, it makes sense when you put it out there why the operators would drag things even down farther.
And but basically this is the reason why relationships using these predicates are significantly slower than relationships with the equal predicate.
Oh. Oh, okay, that would make sense.
Mhm. So
Because
That
all the predicates less than, greater than, less than or equal to, greater than or equal to, all four of those, right? And they
uh,
and the
everyone except the cross, which is
cross
Cartesian, and
product. Yeah.
because even the not equal actually has to traverse through all the index and give you the list of all records except that. Oh, maybe not. Maybe that's fast because it knows all the records. So not equal may be fast as well, but all the other ones are much slower because they don't return just the contents of a single index node. It
Mm,
returns a lot of them.
yeah. That's, I mean,
So
I think in conclusion, we could still keep talking about indexes. There's a
yes,
lot more to say.
yes.
yeah, definitely. And we didn't answer almost any questions. Are there any,
There
Franca?
were some there's a couple that you caught as you went through. Like there was an earlier question about numeric UUID producing smaller index sizes, which you obviously talked about.
Mm-hmm.
Um, is this true when it's a transaction? Is this about during when you were rebuilding the index, or would it rebuild the index only once at the end of the transaction? So if you put like a replace command inside of a transaction, would it rebuild the index during that replace command inside the transaction, or would it wait until
Well,
after?
actually, when I was testing it, I think the index was updated gradually. So even when I started with no index in the beginning, uh, I believe it created the in. Well, is there no? Is there an
But
operation that is that an operation that creates data and turns index on at the same time? I don't think so.
no,
So
I
so
think it has to happen during the transaction.
yeah, so it depends on the if yeah, if you first modify the records and then do something that needs the index, then the index will be rebuilt completely. But if you cause the index to be enabled before making changes, then every change is going to individually update the index, even if you do it for multiple records in a transaction. Because even though you're modifying multiple records, it's still having to update the index for every single change.
It's so interesting. It's a fascinating topic when you get into indexes because
There's a
they're hidden behind the scenes. And
Yeah.
I like the way that Hansa, shows the mapping of like the values, and these are the record IDs that would get listed as part of this, because that's all the overhead that you never see, you know?
So yeah, so one of the first things developers should learn is to work with this dialog and think about the settings for every single field you create.
And turn off quick find.
Yeah, you're right. So this is a very disabling this checkbox is very helpful thing. I know that one guy from ClickWorks, I believe, told me they have internal rule that they always have to disable this checkbox. It's a strict rule for their development that they always disable this checkbox for every field. and they only enable index when they know they will need it.
So if that's disabled and you create a relationship, do you get a warning that it can't index it? I think you do. I can't remember now.
Yes, yes. I just turned it off for lorem ipsum field, so let me try and wait a minute.
Try to,
I may not have
yeah,
tried it,
try, yeah, try click OK after you did it. Like there, click OK
but
now.
interesting is yeah. Now I click OK and go back
Yeah,
there.
the relationship won't work.
Yeah, you see this small sign here says it won't work on in this direction. If I try to create it again now, no, it doesn't warn me. I thought it
Yeah,
would.
I thought I saw a dialogue at some point telling us like try another field, try ID to Laura Ipsum, and then get rid of the other predicate. Try ID to Lorem Ipsum. Yeah, it doesn't warn you.
No, it just shows this small line here,
Yeah,
which indicates it will break in this direction. But I also thought it would warn me, but it just shows this. Interesting. Maybe this is the question that always had wrong in the certification exam. I
yeah.
recall something about it was there.
I I would say as a follow-up discussion to all of this that we could still talk about
Yeah.
indexes
And
in the context of
yeah, and
go to
just as a
yeah.
as a reminder for the quick find,
Hmm.
there is a actually in here when you select a field, I think it's
Yeah, right there. Include field for
yeah.
quick find.
So there is a checkbox whether that field on that layout should be included in the quick find.
Yes, I
So
get told to
if
turn off that checkbox a lot.
so yeah, and by the way, it's enabled by default for any new field that you add. So it's another thing that you may want to disable intentionally because you usually want to control in which fields you want people to search in.
Yeah. We didn't even get to talk about multi-keys. We should talk about that as a follow-up to indexing and go to list of records and all
That
of
would
that.
be fun.
Yeah.
Yes.
Yeah.
Uh,
Like so I learned something this week as well.
ooh,
Hmm.
I'm also constantly learning. I so multi-keys were very fascinating to me, and I was always thinking multi-keys only work in one direction, but multi-keys work in both directions and
Yes, they do.
in interesting ways. And so I can share an example that I had to work on that it just kind of really it was the problem that we're trying to figure out, and I didn't know how to solve it, but I ended up
Yeah.
coming up with a solution for it.
Yeah, we can set multi-keys as a topic for one of the follow-up streams, and I think it's a very nice one because it gets interesting with date ranges.
Yep,
So when you
yep,
want to make a relationship to reveal records with dates between 1st of January and 31st of March, for instance.
yep,
ooh, that would be okay. That would be good.
And now when I mentioned how the greater than and less than predicates are making relationships slow, this is actually the way how to make them fast again.
Oh, wait, you can? Well, you can't leave. Oh my, and we're like 10 minutes over time. Okay,
I
well,
know.
I have to
That's
kidnap both of you and make you return. Obviously. Sorry.
We'll just keep coming up with topics.
Please
Yeah.
do. Uh,
Yeah, I think we are going to end up coming up with two topics every one live stream. So
it's the
I think
infinite topic generator.
I think we'll never run out of topics.
Cool.
Yes,
All right.
okay. With that particular wrap up, this has been awesome. I have learned a lot today. Thank you both very much. This definitely goes
You're
in one
welcome.
in my favorite streams list. I think this is a really vital introduction to how exactly indexes are messing with you or not messing with you. So,
Mm.
uh, with that being said, I'm gonna run the closing music. And I'm gonna bid all of y'all a good day, and I will catch you tomorrow. Okay, now you gotta watch the
Thanks,
music.
Margaret. Yeah.
Thank you.